Well, good evening. Welcome to Lesson 10.3. And this lesson is pretty straightforward. It's the area of circles. Now remember, 10.3, this is the last of the two-dimensional figures. Remember, we've got 9 lessons in this chapter. The first 3 are on two-dimensional formulas. We already did rectangles and parallelograms and squares and stuff like that in the first section. We did triangles and trapezoids, the ones I call the half formulas, because they had a half in them. We did those yesterday with 10.2, and so now we're on 10.3, and we already kind of talked about this if you remember back to March 14th, Pi Day. We talked about area of circles, okay? So there's this really cool proof in your book that shows essentially where the area formula for a circle comes from, and believe it or not, you take a circle and you just divide it up like it's a pumpkin pie, and you just keep cutting it into pieces. Okay, and I'm going to divide it one more time, like this. And so we're going to actually end up with, I think, 16 pieces if I did this right. And then what you do is you take the pieces and you just stack them like this. So you stack them like this, and then you stack the next one the opposite way, and the next one the opposite way, and you just keep doing this. Oops, that should have been straight. And so you get this slightly bumpy surface, but really what you end up getting is something that looks kind of like a parallelogram. Okay, let's see, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. All right, and so basically that's the idea. And if you think about this, the radius here acts like the height of this new parallelogram, and it turns out that the bottom is pi r. And we'll go into a little bit more when we're looking at a little bit better picture of why that's true. But if you think about it, the circumference of this whole, well, we'll do it right now. The circumference of this whole circle is 2 times pi times radius, right? Or pi times diameter. It's the same thing. Okay, pi times diameter. So 2 pi r, but the circumference are all these little bumpy things, and half of them are up here on the top and the other half are on the bottom. So if I take half of 2 pi r, I get just pi r. So to find the area of this parallelogram, it's base times height. Well, the base is a big pi r, and the height is a radius. And pi times r is pi r squared. Now you might think, okay, wait a second here. You didn't really add up triangles. You really added things that have, like right here, if you look closely at that, there's a little curvy bump there. And you're right. So it's not exactly a parallelogram. But the more pieces I cut the circle into, the closer it is to an actual parallelogram. And if you cut it up into hundreds and hundreds and hundreds of pieces, it turns out to be exactly a parallelogram, as the number of pieces gets really, really big. So this formula works. And now you could think of it 2 ways. You could think of it as this is where the formula came from, or you could think of it as this is the actual formula. So area is equal to pi r squared. Now, unfortunately, that's kind of the exciting part. I don't have a whole lot more. You have basically 2 types of problems. You have this, what I call the easy problems, where they come along and they give you a circle, and they tell you the radius is 3. And so to find the area, you're going to always write your formula first. So you write pi r squared. Well, the radius here is just 3. So pi times 3 squared is 9 times pi. The hard problems, and you're going to laugh because they're not really that hard, the hard problems are ones where they tell you that the diameter is 8. So all you have to do ahead of time, if you know the diameter is 8, we should probably give it some units. We'll call it 8 inches. Well, you just take the radius as half of that, so it's 4 inches. Again, write your formula, area equals pi r squared. Okay? And so you get pi times 4 squared, and 4 squared is 4 times 4. Be careful, it's not 8. It's the number one mistake people make with this. 4 times 4 is 16 times pi, and usually we put the number in front, so we'll switch the order there. And that is the area for the red circle. And that's pretty much it. I probably should put an A in there. Okay? Now, you could also do the stuff we did with some of the earlier sections. You can also do, let's take a capsule. Let's say we're doing a pharmaceutical capsule. And the capsule is going to be a long tube, and it's going to have a round end on the end of each side. Okay? And I tell you that the rectangle part is 2 by 7. Find the area of the entire figure. All right, so what you do on this one, let's start with the circle part on the end. If this is a half circle and this is a half circle, then you can pretty much take those off and put them back together and make just a regular circle. All right? And if the height of the circle from here to here is 2, that's the diameter, so the radius must be 1. So the area of the little circle is pi r squared. Well, wait a second. If the radius is just 1, 1 times 1 is just pi. It's just 1, so 1 times pi, the area is going to equal pi. The area for the yellow rectangle is just 7 times 2. Oops, sorry, I broke my own rule. Let's go erase that. Okay, the area of the rectangle is going to be length times width, or base times height. You can do that too, base times height. And the base, in this case, let's call the 7 the base and the height 2, so you get 14 units squared. And so the area of the whole thing is 14 plus pi. Now that's the exact answer. Now if I wanted an approximate answer, I could put 3.14 in for pi, and I would get 17.14. It's not exact. I always like things better when you have the pi in there. But 17.14. We didn't put any units in here, so we'll call these millimeters. And so the area will be measured in millimeters squared. Okay? All right. So that is pretty much all I have for you for area of a circle. So let's keep this video short. Thanks for watching. I hope you have a great rest of the weekend. And I will see you in class on Monday. Bye.